Second type is homogeneous differential equation. So first is the definition of homogeneous function. So function fxy is called homogeneous function of degree n if it expressed in the form fxy is equal to x raised to n phi y by x, that is function of some function of y by x. Or we can define this homogeneous function in simple manner that the function fxy is called homogeneous function if the addition of powers of x and y in each term is equal to n. So the addition of powers of x and y in each term is equal and is equal to n. Then we say the function is a homogeneous function of degree n. For example, this fxy is equal to x square plus 3xy minus 4y square. So is a homogeneous function of degree 2. So how we can verify that this is a homogeneous function of degree 2? So if we observe the first term, there are three terms. This x square is one term, 3xy is the second term, and minus 4y square is the third term. So there are three terms. So if we observe the first term, the power of x is 2, and there is no term of y because y raised to 0 is the power of y raised to 0, that is 1. So y raised to 0 and this raised to 2. So 2 plus 0 is 2. Now if you observe the second term 3xy, then power of x is 1, power of y is 1, their addition is 2. And if you observe the last term, then it is minus 4y square. And if you observe the power of y is 2 and the power of x is 0 and 2 plus 0 is 2. So there are three terms, and in each term the addition of powers of x and y is equal to 2, and therefore it is a homogeneous function of degree 2. Or we can also verify this as a homogeneous function by using the definition number 1. That is, if you take x raised to 2 common from these three terms. So what we have? 1 plus 3. Here we have y by x. We have y by x. And here we have y by x bracket square, y square by x square. So dividing throughout by x square. So take x square as common. So what do we have? That is divided each term by x square, we have this. And this is a function of y by x. This bracket is a function of y by x. So when we say it is a function of y by x, if you observe the first term, it is a y by x raised to 0. This is y by x raised to 1. This is y by x raised to 2. So each term is some power of y by x. So first term is power of y by x raised to 0. It is y by x raised to 1, y by x raised to 2. So this bracket is a function of y by x. And so this function, by using this definition, expressed in the form x raised to 2 function of y by x, phi y by x. And therefore this is a homogeneous function of degree n, degree 2. Okay. So similarly, the next example, fxy is equal to x cube plus 3x square y plus yx is not homogeneous function. Why is not homogeneous function? Because there are three terms, and if you observe the addition of powers of x and y in each term, it is for first term it is 3. For second term, x raised to 2 plus 1, y raised to 1, that is 2 plus 1 is 3. But in the last term, the power of x is 1 and the power of y is 1, addition is 2. So the addition of x, powers of x and y in each term is not equal. In first two terms it is 3 and in third term it is 2. So it is not equal. Addition of powers of x and y is not equal, and therefore it is a not homogeneous function of this function. Okay. So if we take x cube common from this, what we have? 1 plus 3 y by x plus y by x square. What we have here? Y by x square. So this bracket is not function of y by x, because if you observe the first term, it is a function of y by x. If you observe the second term, it is a function of y by x, because it is y by x raised to 1. It is y by x raised to 0. But if you observe the last term, so you cannot write y by x bracket square or y by x. It is y by x. So we cannot write the last term as a y by x raised to some power. It means this function, this last term is what? It's not function of y by x, and so this bracket is not function of y by x. Okay, and so we say it is a not homogeneous function. It is not expressed in this form, x raised to n function of y by x. So this fxy is not homogeneous function. So the definition of homogeneous function is very simple. There are two definitions, apply any one. So next is homogeneous differential equation. Now the main topic is what? Homogeneous differential equation. So the differential equation m dx plus n dy, where m and n are what? M and n are homogeneous functions of same degree, of obviously of x and y, is called a homogeneous differential equation. The differential equation m dx plus n dy is equal to 0 is called homogeneous differential equation if m and n both are homogeneous functions of same degree, homogeneous functions of x and y of same degree. Then we say m dx plus n dy is a homogeneous differential equation. For example, x square plus y square dx plus 2xy dy is equal to 0. This is a homogeneous differential equation because what is m? M is x square plus y square, and it is a homogeneous function of degree 2, while this 2xy is n, and it is also a homogeneous function of degree 2, and so this whole is what? Is a homogeneous differential equation. Next is x cube minus yx square dx plus y cube plus 3x cube dy is equal to 0. This is again a homogeneous differential equation because x cube minus yx square, this is what? Is a homogeneous function of degree 3, while this n means y cube plus 3x cube is again a homogeneous function of degree 3, and therefore this m dx plus n dy is equal to 0. This is a homogeneous differential equation. So the method to solve the homogeneous differential equation. Question is what? Explain the method to solve homogeneous differential equation. So let m dx plus n dy is equal to 0 be a homogeneous differential equation. Obviously, where m and n are what? Homogeneous functions of degree n in x and y, or of x and y. This m and n are functions of x and y, and homogeneous functions of x and y of the degree n. Then we have to solve this m dx plus n dy is equal to 0. So we have n dy is equal to minus m dx, and therefore dy by dx is equal to minus m by n. So we have it is in the form dy by dx is equal to minus m by n. Obviously m and n are homogeneous function of degree n, and so this m and n expressed in the form x raised to n some function of y by x, suppose phi1 y by x, and n is equal to x raised to n phi2 y by x, some function of y by x. This x raised to n we have at the x power of x n in both value of m and n, but we have here the different functions. We have some function of y by x here, we have some function of y by x, but these two functions may not be equal. Okay, and therefore we take phi1 y by x and phi2 y by x, or instead of this we can use the notation phi y by x and psi y by x. These two functions are different. They are functions of y by x, but may not be different, may not be equal, may be equal or different. Most of time these two functions are different. So because these m and n are the two different homogeneous functions of degree n, and that's why this function y by x phi1 y by x function as a y by x depend on the value of m. This function phi2 y by x depend on the value of n, but we have the power of x in both places same n, because this m and n are the homogeneous function of degree n. So we have this, and then dy by dx, this given differential equation dy by dx expressed in the form minus x raised to n phi1 y by x, n is what? X raised to n phi2 y by x. Then cancel x raised to n, we have this dy by dx is equal to minus phi1 y by x divided by phi2 y by x, and then dy by dx is equal to this whole function is a function of y by x now, because the numerator is function of y by x, denominator is function of y by x, and so this whole is as a function of y by x. Suppose this whole function is denoted by psi. So this is a function of y by x. Suppose psi y by x. We denote dy by dx as psi y by x. This phi 1 y by x, phi 2 y by x denoted by psi y by x. Suppose this is equation number star. Then put y by x is equal to v. That is y is equal to vx. And then dy by dx is what? The derivative of v into x is by using u into v rule. V plus x dv by dx. V into derivative of x is 1. Derivative of x is 1 plus x, that is v. Derivative of uh, uh, derivative of v is what? Dv by dx. So u into v rule. This first as it is, second derivative of second plus second as it is, derivative of first. So u into v rule, by using u into v rule, and substitute these values in equation star. So what we have, dy by dx is v plus x dv by dx is equal to psi y by x, means psi v. Okay, so we have this equation. Then x dv by dx is equal to, shift this v to RHS, so psi v minus v, and then shift this psi v minus v to LHS. We have 1 by psi v minus v dv is equal to 1 by x dx. Shift this x to RHS and shift this dx to RHS also. So this x become divided by x and this multiply dx. And so now it is in variable separable form. So after substitution y by x is equal to v or y is equal to vx, the given differential homogeneous differential equation converted to a variable separable form. Then just separate the variables and integrate, we have the solution. So by using substitution y is equal to vx, the given homogeneous differential equation converted to variable separable form. That is the type number 1. That is homogeneous differential equation converted to variable separable form by using substitution y is equal to vx. So what we have, the next step, integrating. After separating variables, integrating. So what we have, integration 1 by psi v minus v dv is equal to integration 1 by x dx plus constant. So integration 1 by psi v minus v dv is equal to integration of 1 by x is log x plus constant of integration, suppose c. Then after integration, this in example we have to find this integration, but now it's keep as it is. Then reput this v as y by x, because y by x is v. Here is our substitution. So resubstitute this v as y by x. We have the in this step. So we have the general solution of the given differential equation. So after separating variables, integrating, and then substitute v as y by x, we have the general solution of the given homogeneous differential equation. So this is the method to obtain the solution of homogeneous differential equation. So this method is important, and we have to explain again it is by using this example. We have to apply the same method to this example. So observe this example. X square plus xy dy by dx is equal to 2xy, or we can write this as x square plus xy dy is equal to, shift this dx to RHS, 2xy dx, or we can write it in the form m dx plus n dy as 2xy dx minus x square plus xy dy is equal to 0. That is, it is in the form m dx plus n dy. So you can observe the coefficient of dx and dy, both are a homogeneous function of degree 2. Homogeneous function. This 2xy is a homogeneous function of degree 2. This x square plus xy is a homogeneous function of degree 2. And so this given differential equation is a homogeneous differential equation. Now we have to solve this problem. So we convert this example as dy by dx is equal to, so what we have, dy by dx is equal to 2xy divided by x square plus y. So convert the given differential equation in the form. So it is given in this form or in this form or in this form. So we have to first identify it is a homogeneous differential equation. Then we have to reduce this equation in the form dy by dx is equal to m by n or minus m by n. We have to reduce the equation in this form, dy by dx is equal to m by n or minus m by n. And then put y by x is equal to v. Next step is what? Put y by x is equal to v, or y is equal to vx. So by using this substitution, what do we have? We have the variable separable differential equation. So substitute y is equal to Vx. So if you identify that the given differential equation is homogeneous differential equation, then just substitute y is equal to Vx. Convert the differential equation in the form dy by dx is equal to m by n, and then substitute y is equal to Vx. And therefore dy by dx is equal to u into v root v derivative of x is 1 plus x dv by dx. Then therefore equation 1 becomes, substitute these values in equation 1. So v plus x dv by dx is equal to 2x vx divided by x square plus x y is vx. So after simplification, 2vx square, take x square as common, 1 plus v, then cancel x square. So we have 2v divided by 1 plus v. So shift this v to RHS, this step. After cancelling x raised to uh, n, shift this v to RHS. So we have x dv by dx is equal to 5v minus v. So here we have x dv by dx is equal to 2v divided by 1 plus v minus v. And now the subtraction of these two, 1 plus v as LCM, 2v minus v into, in bracket, 1 plus v. So v into 1 plus v in bracket. So what we have, it is v plus v square, and after effect of negative sign we have minus v square divided by 1 plus v. Then separate the variables. So shift this quantity to RHS, LHS. So it becomes 1 plus v divided by 2v minus v square dv is equal to 1 by x dx. So now it is in the variable separable form. So 1 plus v divided by 2v minus v is what? Is v minus v square dv is equal to 1 by x dx. And now it is in the variable separable form. If you observe this step, then what do we observe? In LHS, there are all the terms are the functions of x. In RHS, all the terms are function of x. And so it is in the variable separable form. So integrate both sides. So what do we have? Integration 1 plus v divided by v minus v square dv is equal to integration 1 by x dx plus constant of integration. Now the integration of 1 by x is log x, but we have to integrate this 1 plus v divided by v square minus v minus v square, and this is the integration by using partial fractions. So now we have to obtain the first partial fractions of this factor 1 plus v divided by v minus v square. So integration is by using partial fractions. So 1 plus v, take v as common. This is the factorization, v into v minus 1 minus v is the factorization of denominator. Then the factors are what? 1 by a by v plus b by 1 minus v. And then a into 1 minus v plus b into v is the, and v into 1 minus v is the LCM. Then 1 plus v, we have the equation 1 plus v is equal to a 1 minus v plus bv. This is the equation. Then substitute the root of this v into 1 minus v. So v is equal to 0. Substitute v is 0 as the first root of this equation. So we have 1 is equal to, substitute v as 0 in this equation. 1 is equal to a into 1. B coefficient of b is 0. So a is 1. And substitute v as 1. 1 minus v is equal to 0 implies v is 1. So we have 2 is equal to, the coefficient of a is now 0 and b into 1. So b is 2. And therefore the factorization of these what? Partial fractions of 1 plus v divided by v minus b square is what? Are what? V a, that is 1 divided by v plus b is 2 by 1 minus v. And substitute these values in this integration. So integration at in this step, integration 1 by v plus 2 by 1 minus v dv is equal to integration 1 by x dx plus constant of integration. So then integration of 1 by v is log v, and integration of 2 as it is, and integration of 1 by 1 minus v is what? Log 1 minus v divided by the coefficient of v is minus 1 divided by minus. The rule 1 by ax plus b. What is the integration of 1 by ax plus b? Is log ax plus b divided by a. Divided by the coefficient of v, it is minus 1. Is equal to log x plus constant of integration, right? C. Then log v minus 2 log 1 minus v, it is minus now. Because of this divided by minus 1, we have this negative term, is equal to log x plus constant. And then log v minus 2 log 1 minus v minus log x is equal to constant. Then resubstitute v as y by x. So what do we have? Log y by x minus 2 log 1 minus y by x minus log x is equal to constant. So this is a final answer, or we can simplify this step. Then log a by b rule, log a minus log b minus 2. Again here the LCM is x minus y is the numerator, minus log x is equal to constant. Log y minus log x, and this minus log x becomes minus 2 times log x minus 2 log a by b rule, log a minus log b. And then log y minus 2 log x minus 2 log 1 minus x minus y, minus minus become plus 2 log x is equal to constant. And minus 2 log x and 2 log x plus 2 log x get cancelled. So we have log y minus 2 log x minus y is equal to constant. So this is the final answer. Or we can also consider, shift this to numerator. So we have log y minus log x minus y bracket square, and then log y by x minus y bracket square, and then y by x minus y bracket square is equal to e raised to c, suppose new constant c1. So we can also simplify this step, that y by x minus y bracket square is equal to c1 as the general solution, or we can write this as the general solution, or this as the, after substitution v is equal to y by x, we have the general solution. So this is the general solution of this given differential equation. So this is about the homogeneous differential equation. So how we can solve the homogeneous differential equation? By substituting y is equal to vx, we have the answer of the homogeneous differential equation. That is, we have the variable separable form. Then after integration, we have the general solution of the given differential equation. So this is the second type, homogeneous differential equation. So we will see the remaining examples of this homogeneous differential equation in the next lecture.